Hi, my name is Alan Shansky. I'm an intern on the Android team at Google, and today I'll be talking about ListView dragging animations. So the demo today is going to be a simple list view where you can long click on an item, then drag it around, and you'll see that as you drag the item around, it'll actually replace and move around, swap the underlying data set with the other ListView items. So the main trick to doing this animation was to realize that we're not actually going to be moving the views of the ListView around, but what you're going to do is create a bitmap drawable, overlay the bitmap drawable on top of the list view, and then as you're dragging your finger around, what's actually going to happen is that we'll be moving the bitmap drawable, but not the view, which is actually contained inside the list view. So let's jump straight to a demo. And so here we have just a list of cheeses. We can click and hold on one of the items as in order to get hold of it, and then as we drag it around, you'll see that the items around it animate into place while swapping the underlying data set change and moving around. Furthermore, if the bitmap drawable, if the hover view that we have goes outside the bounds of the list view, you can see that the list view starts scrolling and also at the same time swapping elements as we need to. Same thing goes when it's above the bounds of the list view. When you let go of it, the item just animates back into place into the list view, and normal list view interactions ensue. So let's just jump straight to code. The main file to look at here is dynamic list view, which extends a list view object. And as you scroll down, the first important thing to see is that we add an on long click item listener. So what happens when an item has been selected via a long click event? We have to do a few things. One, we have to determine what the position is of the click down event. We have to determine what the item, which item was selected. And then we also retrieve the view that was selected from that spot, as well as the item ID associated with it. Then the important thing that's happening is we call this method called getAndAddHoverView, which returns a bitmap drawable. And what that does is capture the contents of the view that was selected. It takes a screenshot of it, adds that little black border around that we saw right here in getBitmapWithBorder, and the screenshot is captured right here in getBitmapFromView. So once we capture the bitmap and we insert it into the bitmap drawable, the important thing to note is that bitmap drawables have the notion of bounds. So by modifying the bounds, we can modify where it's located, and then when we draw it on top of the list view, it'll move around accordingly to how the bounds were updated. Okay, so moving on to the long item click listener, the important thing to note is that when an item has been selected via a long item click event, there's a few things that we need to do. One, you need to determine what the position is of the down event was. You need to determine the item number that was selected, and you also need to retrieve the view that was clicked as well. So then what we're going to do is call this method called getAndAddHoverView, which is all it's going to do is return a bitmap drawable that has the same contents as the view that was selected. Using a couple methods here below, we're going to capture the contents of the screen, add a black border around it, which you saw in the demo, and then we'll throw all of that into the bitmap drawable, which then will be overlaid over our list view. The important thing to note is that bitmap drawables do have the notion of bounds. So if we do update the bounds of the bitmap drawable, we'll be able to move it around accordingly on the screen to where we want it to be in response to the user touches. Back in getAndAddHoverView, the important thing to note is that we have to make sure that the visibility of the view that was selected is set to invisible. So it's still going to be in the list view, and the bitmap drawable is going to be overlaying the list view, but these two objects are completely independent, even though they correspond in response to the user touches. The other trick that was implemented in order to do this item swapping animation is to know that whenever you're going to swap an item, you're only ever going to swap it with the item right above it or right below it. So that's why whenever a swap animation takes place or a dragging event begins, you always need to retrieve the above item ID and the below item ID. By returning true for stable item IDs in the stable array adapter, which is a custom array adapter I implemented in this project, what you're essentially saying is that every single item in your list view has a unique ID that you maintain yourself, and that will never change for that corresponding object. So we know that this above and below item ID will never change for the above and below views around which you're currently animating. There's some logic here in getView for ID and getPosition for ID, where I was able to actually retrieve a view given some item ID and vice versa. You can look at this later in more detail if you're interested in how I if you're interested in seeing how I did that. But the important thing here is that in dispatch draw, if I do have that bitmap drawable, it will be drawn onto the screen. So what I'm doing here, if I'm not in a dragging event, then my hover cell is going to be null. I won't be drawing anything. If my hover cell is a non-null object, then I will draw it. It'll overlay the list view, since I'm first calling dispatch draw and only then drawing the hover cell on top of it. So now in onTouch event, there's a few things that need to be done. When an action down occurs, I don't yet know whether or not that's going to become a dragging event or not. So either way, I need to retrieve the X and Y coordinates of the touch event. Then in action move, this is where I actually move the hover cell in response to the user touches. Firstly, I calculate the delta by how much the user has already moved his or her finger. And then if I am indeed in a dragging event, then I need to offset the bounds of my hover cell. So here I offset the bounds, I update the bounds, and then I call invalidate, which will call dispatch draw the list view, and then draw the hover cell on top of it. The other thing I need to do is call handle cell switch, which is where the logic for determining whether an item cell swap is going to take place. The way this works is I have a couple booleans that determine whether or not my moving cell, my bitmap drawable, has been shifted up or downwards enough to actually completely overlap the cell that's above or below it. If that is the case, then I determine whether or not it was indeed moved up or moved down and retrieve the item ID corresponding to the cell which will be swapped. After I do that, I need to swap the elements in the underlying dataset change and notify the adapter that data has indeed been changed. So what's going to happen when the notify dataset change method is called is that the list view knows that the data is different, so it's going to invoke a layout and everything in the list view will be redrawn. Before I do that, I want to make sure that the cells that I need to be visible remain visible, while the cell that is still in the swapping and the dragging event is still invisible. So I update those here. And then I also update my above and below view, because now that a cell swap has indeed occurred in the data set, the one either the cell above it or below it is now different. Okay, and now the most important thing here to actually have the cell animate into place when a dataset change has occurred is onPreDrawListener. So what onPreDrawListener does is give you a callback where after onLayout, onMeasure, and onLayout have been called, so after all the values for all of your views, all of your widget on the screen have already been updated, but onDraw has not yet been called. What this lets you do is essentially gives you the power to access all the final values that all the widgets will have, but before they've actually been drawn onto the screen. So you can do some custom drawing here, given the final values, and then once this completes, you can let you can return true for all the other default drawing to actually take place. So now in onPreDraw, the important thing, you always want to remove preDrawListener if you only want to get in here once. And then what you want to do is grab the cell that's being swapped, not the cell you're dragging, but the cell that's going to swap into the new place. You offset it by delta y because you know that it's currently in its final position, but you want it to be in its old position prior to the dataset change. So we calculate this delta y, we set that to be the translation, and then we just simply use an object animator to animate the translation y back to 0 with some duration. So as you saw in the demo, this will actually achieve that sliding effect when a dataset change has occurred. Scrolling down furthermore, we have swap elements, which is a simple method swapping the underlying dataset. And in touches event sended, the only important thing to note here is this object animator that we create. And all this does is animate the bitmap drawable back into its correct position in the list view when a user has lifted his finger up from the phone, as well as reset all our default values back to reset all our variables back to their default values. The other important thing that that was really tricky to do is determining how we can actually have the list view scroll while you're dragging a cell, and making sure that all the above and below item IDs get updated as we need them to. So here in handle mobile scroll is a method that gets called when we so handle mobile cell scroll is a method that gets called every single time the user moves his finger, and that calls this method here. All this does is use a few methods available in Vue to determine whether or not the bounds of the hover cell are either below or above the bounds of the list view. If that is the case, then we'll call smooth scroll by, either up or downwards, and return true. And by returning true, what we're saying is that we are in a scrolling state, in a manual scrolling state created by the fact that the bounds are outside the bounds of the list view. And if that is true, then we'll know that after a scroll has completed, we should continue scrolling because we're still in this manual scrolling state invoked by the bounds of the hover cell. So in order to do that, we add the scroll listener right here. And what that does is every single time an onScroll event has taken place, it checks whether the first or last visible cell in the list view has been updated. If that's the case, then that means that that new first or last item is a potential candidate for an above or below cell to be swapped. And that means that we need to change those above and below item IDs. So we call those methods here. And after the scroll is completed, we call handle mobile scroll once again to keep that scrolling event continuing and keep calling smooth scroll by as long as the bounds are outside the bounds of the list view. Yep. So pretty much you can look at the code if you want to see any more detail. But this is you can take dynamic list view, extend it, include in your project, and that's how you can achieve a list view which can then be dynamically rearranged using user touch events. Thanks.